Hello viewers, today we have a simple task which is expressing sets in roster form. So we have our question number 1 which is saying express the following sets in roster form. Express the following sets in roster form. Okay, that is part 1. Okay, so we have set A which is in set builder form, which is saying that X is such that X is the letter of the word Mwanawasa. So our keyword there is Mwana. Our keyword there is that is Mwanawasa there. Okay, so that's the keyword. So this is in set builder form. So to express this one in roster form, remember roster form is just a way of listing the number of elements of a given set. Okay, so roster form is the listing, okay, of number of elements of a given set. Okay, so we have a word there that is Mwanawasa, so we have to express it in roster form. So remember, whenever you are expressing your set in roster form, if you are dealing with letters, you always use small letters as elements. You don't use capital letters. And if there are letters that are repeating, you just write it once. That's what you do. Okay, so meaning that our set A in roster form will be equal to what? You start with a small letter M, then W, then you move to A, then you move to N, then you move to what? S. Then for those letters that are repeating, you will leave them. So you start with M, you move to W, you move to A, you move to N. A, you've written that already. W is there, A is there, then and S there, then A is there. So that becomes what? Our set in roster form. Then for part 2, what we have is our question is saying that X is such that X is a prime factor of what? 60. So X is such that X is what? A prime factor. So the keyword here, it is what? Prime what? Prime factor of what? 60 there. So in terms of the prime factor of 60 there, you know we have two words there. So we have prime there, which is just representing prime numbers, and a factor there. Okay, so what you're going to do to answer this question is the first thing, you're going to list what? You list what? Prime numbers. Okay, so that's the first thing. So you're going to list what? Prime numbers. Okay, so what are the prime numbers now? So you can just list prime numbers up to somewhere maybe 60. So prime numbers, we have 2 a prime number, 3, then we have a 5, we have a 7, then from 7 we move to 13, then we move to what? We move to 17, we move to 19, then we move to what? We move to 23 there, and so on there. So we're going to list prime numbers. So those are the prime numbers that we have listed there. Okay, remember, prime numbers these are numbers that are divisible by 1 and itself without leaving any remainder. That's what it is. So there are numbers that are divisible by 1 and itself there. So you list out the prime numbers. Then after listing prime numbers, now you also list what? Factors. Okay, remember, when you talk of factors, factors are numbers that can enter into 60 without leaving any what? Remainder there. So we're going to list our what? Our factors there. So factors are numbers that can enter into what? 60 without leaving any what? Any remainder. So what are those? What are those numbers? So I have 1 which can enter into 60. We have a 2. We have a 3. Okay, so 3 can enter into 60. Then now how about a 4? Okay, how about a 4? Yes, a 4 can enter into 60. We have a 5. We have a 6 which can enter into 60 there. Okay, so we have a 6. Then which other number can we use? We also have a 10. We also have a 15. Okay, we also have a 15. Even a 12 is also a factor, and so on. So these are enough. So now from here now, you can now say that set B now in terms of the prime factors, you just look for an intersection. So in short, you're looking for the what? You're looking for common elements. So numbers that are both in the list of prime numbers and also in the factors list there. So what are those numbers? Okay, so I have a 2, okay, we have a 3, and also a 5. So the prime factors, we have 2, 3, and 5. Because if you go on and list up to 60 in terms of the factors, okay, and also prime numbers up to somewhere 60, still you're going to find that the prime factors or the common elements will be 2, 3, and 5. So those will become the prime factors. So we have our C, which is our second last equation. So C is saying that x is such that x is a root of that is x to the power 3 minus what? X equal to 0. So I have to express this one in roster form. So what we're going to do is you solve for x. Okay, that's an equation. So you're going to solve for x. So how do you solve for x? You factor out what? X, because x is common. Then we have x squared, that is minus 1. Then this will be equal to a 0. Then from here, you have two products. So you have x equal to 0 or x squared minus 1. This will be equal to a 0. So now this is x squared, which is equal to 1. So now we have our x squared, which is 1. So you square root there. Even here, you square root. So the value of x will be equal to what? Positive or minus what? Positive or minus 1. Okay. So now you list C now in roster form, because we have three values of x. So we have -1, 0, and what? 1. So that would be what? C in roster form. That's what we do. Then for part 4, we have x is such that x is, we have an equation. So x is n squared minus 1. Then you divide by n squared plus what? A 1. So now they're saying that n is a member of a natural number, and n is less than what? 4. So how do we now express this in roster form? So remember they're saying that we have our equation there, which is n squared, that is minus 1 over n squared plus 1. So n has been defined to be a member of natural number that is less than 4. So when we list our natural numbers, that is n, so up to 4, less than 4. So you have 1, that is 2, 3, then 4 won't be included because it is less than 4, unless if it was less or equal to, then that's when you include that. So here you have n equal to 1, 2, 3, 4, because remember natural numbers are counting numbers, that is 1, 2, 3, okay, going up there, but we are listing those natural numbers that are less than what? 4. So just have 1, 2, and what? A 3. So given that, now since we have our equation, you substitute. You're going to say for n equal to 1, so what will be x? Okay, so 1, that is to the power 1 minus 1 over, that is 1 squared plus 1. Then this will give us 1 squared, that's 1, minus what? 1 over 1 squared, 1 plus what? 1. So this will be 1 minus 1, that will be 0 over 2. So 0 over 2, we have a 0. So again, we do the same for n equal to 2. So we have x that is equal to 2 squared minus 1. Then that is, what is n again? You're going to put a 2. That is squared plus what? 1. So this will be 2 squared. We have a 4, that is minus 1 over. Then 2 squared, that's a 4 plus what? 1. Okay. So 4 minus 1, that's a 3. Then over 4 plus 1, that's a 5 there. Okay. So this is what we have. So again, we do the same for n equal to what? 3. So we have x that is equal to what? Where there's n, you put a 3. So squared minus 1 over, then that would be 3 squared plus 1. So this would be 3 squared, that's a 9 minus 1 over 3 squared, that's 9 plus 1. So this would be 9 minus 1 that's an 8, then 9 plus 1, that's a 10. So that can be reduced. He said 2 into 8, you have a 4, then 2 into 10, 5. So now you're going to list your C, that is D, that is E. So you're going to say E in roster form. We're going to have 0. Remember, for n equal to 1, what 0, then 3 over 5, and 4 over what 5.